Hello students, welcome back. In last video, I was talking about core components of Hadoop, that is HDFS and MapReduce. Now, I will explain them in detail. So, HDFS is a distributed file system of Hadoop. It is designed to run on commodity hardware. You already know what is commodity hardware. Commodity hardware is average configured computer. So Hadoop or HDFS doesn't require high-end configured computer. It is distributed, scalable and portable file system written in Java for Hadoop framework. So it is distributed because all the files are stored in a distributed way on different machines. It is scalable. You already know what is scalability. It can handle any n size of data for storage purpose. So as we increase the size of data, Hadoop HDFS can store that data simply by adding more number of nodes. It is portable. You can use it on different operating system, different computer architecture. HDFS is the primary storage system used by the Hadoop application. Hadoop uses only HDFS for its storage system, not other file system. So HDFS basically creates multiple replica of data blocks. So more than one copy of the data blocks will be created and distributes them on compute nodes throughout a cluster. So data blocks will be replicated and distributed on different compute nodes throughout the cluster to enable a reliable, extremely rapid computation. So if data is replicated, it is available on more than one nodes. That it means we have backup. So it provides reliability and extremely rapid computation, because if computation is going on slower on some node and the same copy of data is available on some other node and that performs better, then computation can be transferred to that node. So it increases the computation speed. Highly fault tolerant. So obviously when we have backup copy of data on different nodes, and if one node goes down, one task goes down, then we can re-execute on that task on some other node because we have backup copy. Also, due to replication, it also provides high availability during execution of parallel application. Obviously, data is highly available because it is stored on 3 nodes. So you can get it from any nodes. Suitable for application that have large data sets. So obviously Hadoop is designed for large file system, big data. It is not suitable for smaller file system. So how HDFS work? We can understand it through an example. So HDFS is a block structured file system, means all the files are stored in the form of block. So that is called block structure. So and break a file into fixed size data block. So a file is break out into a data blocks, more than one data blocks depending on the block size. So you can configure block size in your installation of Hadoop. So by default now in the recent version it is 128 MB. So it doesn't matter, you can also set it 64 MB. That is not an issue. So suppose default block size is some MB, suppose it is 64 MB, then data block will be, suppose a file has size more than 64 MB, 128 MB, then that file will be splitted into the 2 data blocks, each of 64 MB, right? And creates multiple replica of blocks. And also you can set default replication factor to some number. So by default it is replication factor is 3. So suppose if you your cluster has more than 3 nodes, then default replication factor will be 3. But suppose your cluster has only 1 node or 2 node, that is less than 3 node, then the default replication factor 3 is meaningless, because you cannot replicate at the 3 places, because you doesn't have 3 nodes, right? So if you have more than 3 nodes, by default the default replication factor is 3. Again, you can configure the default replication factor in your installation. So the blocks created will be replicated at 3 nodes. How? Suppose we have 2 files. File 1, it has some MB greater than 64 MB. File 2, it is also greater than 64 MB. Suppose this file 1 is greater than 128 MB, right? Then it will be splitted into 3 data blocks: 64 MB, 64 MB, and rest of MB. And file 2 is of size greater than 64 MB, then it will splitted into 2 data blocks. First one is of 64 MB and second one will be of rest size. Now how replication happens? So we have, suppose for file 1, this data block. So these are the data block ID that is created by name node. So for block 1, you can see here that it is stored on first node and then third node and fourth node. Similarly, data block 3 is stored on this second node, third node and fourth node. Data block 4 is stored on first node, second node and third node. Similarly, for file 2, data block 2 is stored on first node and second node, and data block 5, it is stored on first node, second node and third node. So internally HDFS manage where to store all this data at the 3 places. Now HDFS has various components. You can also call it as daemon process of HDFS: name node, secondary name node and data node. So name node basically, so Hadoop or HDFS works on master slave architecture. There is one master node and rest of the nodes are work as slave node, and master node coordinate all the slave nodes. So there is one single master node and rest of the node will work as slave node. So name node, this daemon process will run on master machine, master node, and it manages the file system namespace and regulates access to the files by client. So all the file management activity, name spacing, naming and control of file access will be managed by the name node. Also, name node assigns block ID. So when a file is splitted into more than one block, so block ID, name of the blocks or ID will be created, will be assigned by name node of a file, and stores metadata of the file system in the main memory, providing fast access to this information. So what is metadata? When a file is stored in name node, so these will be the part of metadata, that is list of files, how many files are there, list of blocks for each file, right? When a file is split into more than one blocks, so for each file how many blocks are split, breakdown, list of data nodes for each block. So when it data block is replicated on different data nodes, so it also maintains the information, that is which block is stored on how many nodes, how many data nodes. File attributes like creation time, replication factor, all these things part of the metadata are stored in main memory of name node, so that it can be accessed in the real time. Now we come to the slave machine. So there are more than one slave machines depending on your availability of the computer. So data nodes, this daemon process run on individual slave machines. So if there are n slave machines, so there will be n data nodes will be running on the n slave machine, and it manages storage attached So what are the storage attached? Basically blocks of multiple files, right? Name node doesn't store any file. Files are basically stored on data nodes. Name node only contains the information, metadata about the file. So files stored in the form of blocks on the data nodes to the individual nodes. Internally, a file is split into one or more blocks, and these blocks are stored in set of data nodes. The data nodes are responsible for store and retrieve requests from the file system clients. So data nodes manage storage and retrieval. Data node also performs block creation. So when file is transferred to name node, it is directly transferred to one of the data node, and then data node is split into the different blocks, and it can also create delete the block, and also it can create a replication. For one block it is create 2 additional blocks and transfer to other data node. So data nodes perform all these operations: block creation, deletion and replication upon instruction from name node. I already told that name node is the coordinator. It will manage and coordinate with the all data nodes. So a data nodes cannot take independent decision. It has to coordinate with the name node. All the information will be stored at the name node. So all the instruction for these operations will be provided from name node, and data node performs all these operations. Periodically sends a report of all existing block to the name node. So name node must have all the information about the blocks residing at the data nodes. So all the data nodes will send their reports, internal reports, their report about their status of data blocks to the name node. Now what happens, suppose if name node has been failed? If the system on which the name node is running on, if that system goes down, right, then we must have a backup node. So for that purpose we have a backup name node, that is called secondary name node. So secondary name node is not alive all the time, but it periodically wakes up and get the current details, current update from the name node, and when name node fails, it replaces the name node and work as a full-time name node, right? So now this is the HDFS architecture. You can see that name node coordinates with the data nodes, and name nodes manage all the metadata information, name of the files, replication, their location, their replication factors, etc. Data nodes, these data nodes actually store all the blocks. All the blocks are stored in the data nodes and they replicate on different nodes. Rack 1, rack 2, rack are basically the simple rack that you can imagine, that can store, that can accommodate more than one machine, more than one computer. So rack basically a kind of container that can contain more than one computer in one rack. So data nodes basically stored in the different racks. So if there are, suppose there are 20 data nodes, and one rack can capable to accommodate 10 data nodes, then one rack have 10 data nodes, another rack have the rest of the data nodes. Now what is MapReduce framework? So MapReduce is an efficient, scalable and simplified programming model. So MapReduce is a programming model. See, HDFS is basically used for storage purpose. Now we have to compute the data residing on the HDFS. So we require some kind of programming, parallel programming. So MapReduce provides that parallel programming model for large scale distributed data processing on large cluster of commodity computers. So it is scalable. It can process data of n number of size. Simply you have to add more number of nodes. and it will handle any large scale size of data. So that is called, it is scalable. So MapReduce program can run on Hadoop in multiple languages like Java, Python, Ruby, and C++. So you can use MapReduce framework in any of the language. Suppose if you know Java, you can use Java. So MapReduce is not a programming language, it is a programming model, right? And you can choose any programming language, either Java, Python, Ruby, C++, and you have to use API, library of MapReduce programming model for that language. So there are already available programming MapReduce API for different languages, Java, Python, and other languages. Process large volume of data in parallel. So it is a parallel programming model. So it processes large volume of data in parallel. How? By breaking the job into independent tasks across a large number of machines. So suppose one job is executing and one job is executing a big size of data. Then that job will be splitted into different tasks for different blocks of data, right? And all those independent tasks will be executed across different data nodes, different machines. So simply one job is, suppose there is one job that is executing 10 GB of data, right? So now 10 GB of data is distributed on different nodes, different machines. So now the job will be splitted into different tasks. So job means one single application and task means the different splitted part of the job depending on the blocks, and task will be executing on different machine, right? Why it is called simplified programming model? All parallelization, intercommunication, and fault tolerance are handled by a runtime system. So if you remember in the previous lectures, I have mentioned that in the traditional distributed computing system, when we write parallel program, then we have to write code for all the tasks for parallelization. Means how do you parallelize the job, how will distribute the job, how will you distribute the data on different nodes. All these things have to be programmed. It is the programmer's responsibility to write the code for all these things for parallelization. And also when different machines are communicating, so inter-machine communication, you have to also make provision in your code so that different components can communicate. And fault tolerance, you have to also make some provision for fault tolerance. So why MapReduce is simplified? Because you don't have to concern about all these things: parallelization, inter-machine communication, and fault tolerance. It is not your responsibility. The underlying runtime system will handle all these things. You have to simply focus on write your actual computation code. Management part is not your responsibility, right? So MapReduce program consists of two functions, mapper and reducer, which runs on all machines in Hadoop cluster. So let us see what is mapper and reducer, and both takes input and output in the form of key value pairs. So MapReduce framework consists of two functions, mapper and reducer. So mapper operate on set of key value pairs. So the data set will be in the form of two components. One is called key and corresponding value. That is called key value pairs. Map is applied in parallel on input data set. So there are more than one map operation, mapper function will execute on different blocks of data, right? So because there are n number of data blocks, so depending on that, so n number of mappers will be executed for each data blocks, right? So that is how the parallel computation will work, unless if you are not executing more than one task. So So how can you achieve the parallel computation? So simply for there are n data blocks, it means that you have to compute n task, and for each task there will be n number of mappers. So for n task there will be n number of mappers. So the mapper takes the input. For example, suppose this key value pair name is named as K1 B1 pairs from HDFS. So input reads data from HDFS, the data resided in the HDFS in the form of key value pairs, and produce a list of intermediate key value pairs. So it will basically transform one key value pairs from one form to another form. So this will be the from one key value pairs it will generate more than one key value pairs. So that's why it is called list of intermediate key value pairs. And then mapper output, this is the mapper output list of key value pairs are partitioned per reducer. That is, now we can choose how many number of reducer we want to execute. Number of map task or mappers it totally depend on how many data blocks are there. But you can choose, you can configure how many reduce tasks you want to execute. So suppose I want to execute only 3 reduce tasks. So all the input, all the intermediate key value pairs will be divided into the 3 reduce tasks. But key value pairs with the same key must be go to the same reduce task. Let us see how does it work. Reduce function. So again, reduce function operate on set of key value pairs. The reducer takes output of mapper. So basically this is the list of key value pairs, and then we will come how it is shuffle and exchange. So after shuffling and exchanging, it will be transformed into this form key and list of value. So if key is K2 and value is V2, then for same for the key value pairs having the same key, their value will be collected at one place. So all the values V2 having the same key K2 will be listed in one place. So that's why we will call it as the K2 and list of V2. So now this output or this data will be fed to the reduce function as input, and then reduce function operate on this data and it will produce another key value pairs. This K2 and this K3 can be same depending on the nature of computation. Now combiner function, it is optional. It is up to you depending on the complexity of the problem. You can and size of the cluster. You can use combiner function or not. So its internal functioning is same as a reducer, or you can say that it is a mini reducer. The only difference is that the input for reduce function is output of all the map task, all the mapper function. But if we are using combiner, then combiner work locally on one machine. So suppose if one machine suppose there are n number of data blocks and we have only 3 machines, right? If we have only 3 machines, so it means that on one machine there may be more than one map function will be executed, mapper will be executed, n by 3 mapper will be executed on each machine. So if on one machine we make reduction, local reduction on that machine, so for all 3 machines we make local reduction using combiner function. So combiner function is basically work as the reducer for the one single machine, and reducer will work on the for all the output of the mappers on all machines. So this is the general framework, general control flow, how MapReduce algorithm work. So input data, it will be basically read through mapper in the form of key value pairs. So each, depending on the number of blocks of data, each mapper will read key value pairs from the input data set, and this input data set must be resided in the HDFS. Now output of mapper will be, these are the list of K2V2, list of K2V2, list of K2V2. So intermediate value of or intermediate output of mapper, they will be shuffle and exchange. Why do we make shuffle and exchange? For example, so that all the key value pairs with the same key can go to the same reducer. If we want to make some reduction operation, then all the value for the same key must be on the same reducer. For example, if some key value pairs for the same key will be on one reducer and some part will be on another reducer, then you cannot add or you cannot make reduction or any kind of operation on them. So all the value with the same key must go on the same reducer. So that's why we make shuffle and exchange. So shuffle and exchange operations are applied so that all the key value pair with the same key can go to one reducer, and then all these outputs will be fed to the reducer, and reducer produce their output. So how shuffle and exchange process work? Output pairs of mapper. So suppose we are using combiner also, right? So output pairs of mapper are locally sorted and grouped on same key and fed to the combiner to make local sum, right? Then intermediate output pairs of combiners are shuffled and exchanged between machine to group all the pairs with the same key to a single reducer. That's what I am saying. This is the only one communication steps take place and handled by the underlying system of MapReduce. So I have already mentioned it that in case of parallel programming or distributed programming, tasks have to communicate to each other, and execution time will be highly affected by the number of communication. So we always try to reduce the communication. So that is the advantage of Hadoop, that only one communication step occurs at the time of shuffle and exchange, and before that and after that all the tasks will be executed independently without communicating to one another. So that is the very big positive things or very big advantage of the Hadoop. So how MapReduce co-located with HDFS? How? So there are now different daemon process. HDFS has its daemon process name node, data node, and MapReduce has its daemon process job tracker and task tracker. So job tracker controls, like name node governs the management of the file system on master machine. Similarly, job tracker also controls the computation part on the slave node. So job tracker and name node will be executed on master machine, and on the slave machine data node and task tracker will be executed. So how many number of slave node, that number of data node and task tracker will be executed. So task tracker and data node will be resided on same node, same machine, so that task tracker can directly access the data from the data node. So data node manage all the file system storage functionality, and task tracker controls the MapReduce execution on data nodes, on slave machine. So basically these are the underlying processes for controlling the computation part and controlling the storage management. So in next video we will discuss the advantage and limitations of using Hadoop. For that we will stop here. Thank you.